Day 294 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 221, maximal square. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Given an n by n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. So that sounds simple enough, but let's go ahead and take a look at these examples so we can make sure that we're doing it correctly, right? So in example 1, we have our input equals a matrix. This is the matrix right here. 2D array or n by n matrix grid with the first row being 1 0 1 0 0, second row being 1 0 1 1 1 1, third row being 1 1 1 1 1 1, and the last row being 1 0 0 1 0. The output is 4. So luckily they give us this nice picture right here in example 1 to look at. So let's go ahead and take a look at it. Now as you can see, first off, you can see each one of these arrays inside the initial 2D array represents a new row. So this right here represents row 1. This right here represents row 2. This right here represents row 3. And this right here is row 4. So what we want to do is we want to find the largest square that we can create with all ones. So in this case, and then return the area. So in this case, they draw a line around the squares for us, and in this case there's two squares, but they're equally the same size, so which is 2 by 2. So remember, the area is length times width. So the area of this square would be 4, and the area of this square would be 4. So that's why the output is 4, because as you can see, we could the length, we come down 1 2, go over 1 2, boom, and that square. Same with the other square with the red. Same with the green square as the red square. We could go down 2 and over 2, and so the length and the width both being 2, we multiply 2 by 2 equals 4, and that's how we get 4. So let's go ahead and look at example 2. In example 2, we have the input matrix equals another n by n grid. This time the first row being 0 and 1, second row being 1 and 0, right? And this time the output is 1, because when you do length times length, this has a length of 1, this has a length of 1, so 1 times 1 is 1. Same thing with this square. This has a length of 1, and this has a length of 1, so 1 times 1 is 1. Squares are the same size, so we could just return 1. So let's look at example 3, where they might try to give us a trick question where this time the matrix equals an array of n by n matrix, and there are no ones, right? It's just one row, one square is 0. That square is a 0, but remember, we want the squares with ones in it, and since there are no squares with 1 in it, in example 3, we could just return 0 for the output. So now that we understand the question, let's get into the fun part, the actual solution. Solution's not that difficult, as I'm sure y'all already know. That's how we like to do. So, excuse me, y'all. Let's get into it. Now, the first thing we need to do is we need to ensure the matrix is not empty, and if it is, then we can just return 0. So in order to do that, we're just going to say guard matrix dot count is greater than 0, and so this right here is going to represent the rows. Now we got to check the columns, so we're going to say and matrix square bracket 0 dot count, and this right here represents the columns. We're going to say is greater than 0. Then else we could just return 0, just like that. Boom. Now we need to create our dynamic programming table. We're going to initialize it with 0, and it's going to have the same dimensions as the matrix. So in order to do that, we can just declare a variable. We call it square. Set that equal to an array. Open up the parentheses of repeating, colon, it's going to be repeating another array because remember it's a 2D array, so we're going to say repeating array. Then we're going to open up the parentheses and we're going to say repeating colon 0 comma count colon matrix square bracket 0, come outside the square brackets, still inside the parentheses, and say dot count. Then we're going to come outside of those parentheses, but still inside the other parentheses, because remember this right here just represents the array that's inside of this array, so we still need to do this array's count. So we're going to say comma count colon matrix dot count, just like that. Boom. Now we need a variable to track the maximum side length of the square that's found. So we could just declare a variable and we could say cur max length, and we could just set that to 0 to start. Now it's time to iterate through each cell in the matrix. So in order to do that, we'll say for I in 0 dot dot less than sign matrix dot count, open up the brackets. Then we're going to say for j in 0 dot dot less than sign matrix square bracket 0 dot count. Then we're going to open up the brackets and we are going to say if I is equal to 0, or, so we're going to say 2 vertical lines, j equals, it's going to be, make sure it's equal white space on each side of the equal signs, equals 0. Then we can open up the brackets. Now if the cell is in the first row or the first column and its value remains as is, but we still need to convert the character into an integer. So in order to do that, because remember these are strings, so we need to convert them into integers. So in order to do that, we'll say square bracket I, come outside that square bracket j, equals int, it's going to be int, open up the parentheses, string, open up the parentheses, matrix, square bracket I, square bracket j, just like that. Then we'll come right here and we'll say else if, give y'all some space so you can read it easier. Say else if the current cell is 1, we need to check the minimum of the top, the left, and the top left cells so we can form a square, and add 1 to form the largest possible square ending at this cell. So to do that, we'll open up the brackets. We're going to say square bracket I, square bracket j, equals min, open up the parentheses, we're going to say min again, then we're going to open up the parentheses, we're going to say square bracket I minus 1, come outside of that, then we're going to say square bracket j. Then we're going to come outside that square bracket, we're going to say comma square bracket I, come outside that square bracket j minus 1. Then we're going to come outside that square bracket and we are going to say comma square bracket I minus 1, excuse me. Then we're going to say square bracket j minus 1. Boom. Then we're going to come right here. Oh, sorry, y'all. Put the parentheses should be right here. We should close those parentheses right there. We could get rid of this parentheses. Then we're going to come outside of this parentheses and we say plus 1. Boom. Now we need to update the maximum square length that we have found so far. So in order to do that, we just come right here. We'll say cur max len equals max, open up the parentheses, cur max len, comma, square bracket I, square bracket j. Now we need to return the area of the largest square found. So remember, that's just the length or width times length. But in this case, we're just going to say return cur max len because it's a square. So the length and the width should be the same. So we could just multiply cur max len by itself. Boom. And that should give us the answer or the output that we're looking for. So let's go ahead and run it. Make sure it runs. Okay, we got an error. So we're missing condition and if. So let's see. Oh, this should be else if matrix square bracket I square bracket J. Sorry about that. Square bracket J. This is where we're checking to see if the cell is equal to 1. So we say if matrix square bracket I square bracket J equals, open up the quotation marks because it's a string, and we're going to put a 1 in there. So it's going to be a 1. So if it equals 1, boom. Now let's run it and see how it runs. Sorry about that, y'all. Okay, not done yet. Was it saved? It must be unwrapped. So what where we at? Let's see how we could we could just put a unwrap it. We could just put an exclamation point right there to unwrap it. So let's run it again. Let's see if this time, third time's a charm, and it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. Let's see. Okay, look at that. 12 milliseconds beats 37.89% of users with Swift, y'all. But don't worry about those numbers. We'll get those numbers up further down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us. And I feel like this is a good solution for that, easy to understand. So make sure y'all go over this, read it, learn it, love it. Get one more look at the code, y'all. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.